Welcome to the video on clustering. So what is clustering? Let's look at it. So clustering comes under unsupervised learning. Unsupervised learning is a subset of machine learning. So it does not have a response. So data set does not have response variable. It only has independent variable. And based on this data, we build a machine learning model, and that's why it's called unsupervised learning, because there is no response variable to supervise the learning process. What clustering does it groups different records into clusters based on similarities and dissimilarities among them, among these data points. So data points within each cluster are similar, while they are quite dissimilar to that of other clusters. That means they are dissimilar to the data points from other clusters. So set of data points are assigned into subsets so that the observation in the same subset are similar, and different subsets are dissimilar. Although it is not an easy task to define similarity, because it's a very philosophical question, but we will use a pragmatic approach to do that. So let's look at one example. So the examples of clustering, how clustering helps in real life problems. So there's document classification. So what we do is we can use clustering to segregate different documents based on different parameters defined by the domain experts. Another example is web. So what we can do is, using clustering techniques, we can divide users based on their access patterns of the web pages. Like certain user would love particular news article, another user may like entertainment news, one user may like crime news, so something like that. So this is just one example. And we can also use clustering to divide web pages into different groups based on the content. So market segment, so based on buying and spending pattern, we can group different customers into different clusters. Then bioinformatics, so we can use clustering technique to cluster gene expressions to understand gene functions, regulations, cellular processes, etc. So this is a pictorial representation, these two. So this is a data point which has been this is a data which has been uh, divided into three clusters, based on similarities. And when you plot it, it looks something like this. So there are two clusters because the data points in this cluster are very close to each other, while data points in this cluster are close to this cluster. So that's how it is. So there are types of clustering. So there are mainly two types of clustering: hierarchical clustering and non-hierarchical clustering. So each type has its own subtypes. So for example, non-hierarchical clustering, the examples of non-hierarchical clustering are k-means, k-meroids, Gaussian mixture model, etc. We'll see in details what are they. Then hierarchical clustering mainly has two subtypes: agglomerative methods and divisive methods. So a lot of research is going on, by different institutions, people from statistics and data science, and they're coming up with research papers. So you can go online and read those research papers. They're very interesting. Clustering is a very interesting topic. Many researchers have come up with their own methods, adding few steps or new steps to the traditional clustering techniques like these, and also to improve the existing algorithms. So you can read those research papers and get better understanding of clustering. It's a very vast field actually, and very useful. So this is the example of k-means is example of non-hierarchical clustering. We'll see how it works. So what we do is, if we have a data points, they're scattered. So uh, k stands for basically number of clusters, and which is called centroid, and each cluster has its own centroid. So initially we decide how many clusters we want. Like, we'll see how to decide on the number of k later. So then let's say we decide k as 3. So we are going to have 3 clusters, and each cluster is going to have one centroid. So we randomly select one centroid, sorry, the values of each centroid. And then what we do is we assign data points to each cluster by uh, a distance measure between the centroid of that cluster and all the data points. So likewise, we calculate the distance and similarities, and then assign each data point to each cluster. Then what we do in the third step, we recalculate the centroid. Now, since initially we just randomly picked up us 3 centroids with different values, and now once we have assigned data points to each cluster, now cluster has certain data points. So based on the values of data points, we recalculate the centroid for each cluster. These are 3 steps we follow, and we repeat all these 3 steps until convergence. We reach the final stage where there is no change in centroid values. So this is one example here. So what I've done is I've used k-means algorithm to build a model here. So these are the data points, right? These are the data points. I've used different coloring, red, blue, and green. So I randomly picked up 3. So my k here is 3, and I picked up 3 different centroids, randomly. One is here, starting, one is here, another one is here, another one is here, and I keep iterated. I keep repeating this method only, these steps, and how, see, the first centroid has moved slowly like this, and it has reached here. Second one has moved like this, and it has reached here. Third one has moved like this, and it has reached here. In 10 different iterations, they finally reach their center point. So this is how we do k-means. So for this similarity measure, we use Euclidean distance in k-means. And then this is the formula. I'm sure you would know what is Euclidean distance. Basically, let's say we want to calculate Euclidean distance between these 2 points. Now this is 2-dimensional, y and x. So this will have coordinate like x1, y1. This is x2, y2. So we take the difference here, x1 minus x2 square plus y1 minus y2 square, and sum them and then take the square root. This is called Euclidean distance. So what we do is, to recalculate the centroid, what we do is that we take the average of coordinates. So like in this, let's say in this cluster, we take the average of x coordinates and y coordinates of all the data points, and that becomes the centroid for this cluster. Similarly for these 2 clusters as well. So this is the example. Let's say for this example, like if this cluster has got n1 points, so it has x coordinates and y coordinates for each point, right? So all x1, x2 to xn1 divided by n1, and y1 plus y2 to plus yn1 divided by n1. So this gives us the centroid for this one. Let's say this one has got n2 data points, the n3 data points. Likewise, for each cluster, we can recalculate the centroid. So example of k-means. So here is the example. What we have done is, using the k-means, we have this is the original picture, 128 by 128. Using k-means, I have compressed it to this, which has got only 16 colors now. So although the quality has been compromised, but it has been compressed substantially compared to the original. So this is also one example of how to use clustering in real life data. So you can use k-means or some other clustering method to compress an image. So what I've done is I've given you a sample code here, which I have written for if you want to write k-means algorithm from scratch, you can use this. But these are all sample codes, okay? So they are not completely they're not complete. So I have just provided the basic ones, the main lines. The rest you need to write down if you want to. You can take the help of these codes and you can write your own function. So first function is to initialize the centroid. So rand in idx, basically what it does is it takes the number of rows in the data x and then sample it. So if there are, let's say, 100 sample, we have already seen sample in other videos. So if there are 100 rows, then it will give rand idx will have 100 values, 1 to 100, but in a random way. First value could be 100, then 80, then 29, like this. And then we are using the same, and we want k centroid, right? So we use this 1:k, so it will pick up first k indices from this, so which are randomized, right? And then we will pick up those rows from X, so that will become our centroid. And then this is the function we need to write, find closest centroid. So what we do is we basically, this is a variable, which has 0 repeated n rows. If n is the number of rows in, or example in X, has been repeated, 0 has been repeated that many times. Basically, it will store the indices of all the centroid for each row. That's what it will do. So there are two for loops. One for loop is for the example from the X, and second for loop is for the number of centroids. So for first row, it is calculating, and this is another variable which stores the value of distance from each centroid. So in the first for loop, we picked up the first row, and then in the second for loop, what we are doing is we are calculating the distance of the first row from each centroid, and we are storing in this variable. And when then we come out of this second for loop, we are storing, what we are using here is the which dot min function. What it does is it takes the index of the minimum value in this, and then we are assigning that value to the first value of idx. And then so this idx will contain the index of minimum distance from each row. That's what it will do. You can take a pause and try to understand this. It's very simple. And then once we have assigned the values, the rows to their respective centroid, then we need to recalculate the centroid, right? In the previous slide, we saw all these three steps. So this is what we are doing here. We are basically taking the call means. Okay, this is a vectorized version. Remember this. So what we have done here is, instead of summing and then squaring and then taking the square root, we have just vectorized it, and we have not taken the square root because it doesn't make any difference, right? It's going to give the same values. So, and then here we are using call mean function to get the mean of each dimension. So recalculating. So just go through this code. It's very simple. You can use these codes to build your own function and own, your own personal, k-means algorithm from scratch. So how to check the quality of a model? So what we do is, the purpose is to minimize the intra-cluster distance. What it means is, the data points, the distance between two data points within a cluster should be minimized. So all the data points should be closely knit. That's what it means. And then maximize the inter-cluster distance. That means between two, we have to maximize the distance between two clusters. That means we pick up a data point from one cluster and data point from another cluster, and the distance should be maximized. So here is a pictorial description of that. So the first one says that the distance between these two data points, or these two data points, or these two data points should be minimized, and distance between the data points from different clusters, this and this, should be maximized, or this should be maximized. That's what it means. So what is cost function? Is basically sum of square distances of each data point to its centroid. So there is a centroid here. We calculate the sum of, first we calculate the distance between centroid and each data point within this cluster, right? And then we square them and sum them up. That becomes your sum of square distance. That is in one cluster. We do the same thing for this cluster and this cluster, and then add all those values. So that becomes your sum square distances. That is a cost function. So total sum of squares, what is that? So between some squares, right? So between these and these and these three, that means it is this one, intercluster. And within some square, this is what this within some square is, what we saw here. We add them together, that gives us total sum squares. And then, so between some square divided by total sum square should be large. That's what it says. So choosing k, how to choose k? As we saw initially, we just assumed that a cluster may have 1, 2, 3, 4, k's. That means clusters, number of clusters. But look at this data point here. Look at these two pictures. You don't know whether it should have 2 clusters or it should have 4 clusters. Same data points. So there's a confusion. So what we do, so that's what I said, just if you look at these two pictures, you will never know like how many cluster we need. So there's something called elbow method. What it does is it plots cost function versus the number of k, you know. So what we do is we calculate the cost. Let's say in the first iteration we picked up k as 2, and then so we calculated the cost for that model. Then next iteration k is 3, and we calculated cost for this k as 3. We go on like this. So we build that many models, you know, and then we keep calculating cost and see which one. And if you see, it will form like this elbow. It looks like elbow. So it will reduce suddenly, sharply, and then the decrease in cost will slow down. Actually, it will flatten out here. So this joining point, you know, this like elbow. So this point is your most optimum k value. This is elbow method actually. So how to do k means in R? So let's say we have example. I mean, I have not mentioned the values because they are large data points basically. So to save space, I have just not mentioned. So this is the code actually. So see, I've converted this x1 x2 into a data frame. It's called data. We are going to use the same data throughout this presentation because we are going to use this in other algorithm also. And there is there's a function called k-means. So in R, so what it asks for different arguments. So first is data, then center. So k is 3 here, and start means how many times will restart. You know, like so k if after building the model, if you display the k, what it gives is these are the centroids basically. So because we have picked up we've decided on 3 clusters, so it has given us centroid for 3. Okay, these are the clusters. Okay, basically the first data point is in the first cluster, second data point is in the third cluster, likewise, you know. Then within cluster sum square, so this is what we saw, right? So for each cluster, this is the sum square, you know, for each cluster. There are 3 clusters of 3, and this is between sum square by total sum square. So 75.7%. We earlier we saw, right? This should be very large value. And then it has this model also has some other components like cluster. So if you type this, we have assigned this, named this model as km. So if you type km dollar cluster, it will give you this value. Km dollar centers, it will give you these values, you know, like that. Total system withins is like this withins, you know, this total withins, it will add all the 3 values and give you the value. Between, then size means, you know, how many clusters and all that, how many iteration and stuff. So let's plot this. So when we plot, see, this is what it has done, you know. It has taken these data points and divided into 3 clusters. Soft and hard clustering. What is soft and hard clustering? So if you look at the example of k-means, what it does is it assigns a data point, each data point to only one cluster. So a data point can only belong to one cluster. This is called hard clustering. In soft clustering, what we do is we assign different probability. Like if there are to each data point. So if there are 3 clusters, we will assign the probability value to each data point. For example, data point 1, you know, so it can be assigned a probability of 0.1, you know, that means it has a probability of belonging to cluster 1 as 0.1. It has a probability of belonging to cluster 2 as 0.5. It has a probability of belonging to cluster 3 as 0.4. So so it gives us the probability of a data point belonging to different cluster rather than just saying that, okay, this data point belongs only to this cluster. You know, that is soft clustering. So example of soft clustering is Gaussian mixture model. What it does, it also takes into consideration variance. So we have seen variance, right? So single variable will have variance and multiple variables will have covariance. So it determines the membership of probabilities, right? That's what we saw. And it takes into account the mean and variance. Mean I stands for cluster. So each cluster will have its own mean and each cluster will have its own variance, right? So there is a package called Mix Tools you can install on your R. and that package has a function called mv normal mix em, and it asks for different parameters like data arb var means true means each cluster will have its own variance. Center is 2, like 2 cluster and epsilon values, and then probability. So this is the name of this model that we built, right? So this has a component called posterior. So this gives us the probability value, right, of each data point belonging to different clusters. So we'll plot, and see what happened. So you see, we picked up only two centers, right, two clusters. So it has created this clustering. Considering whichever has got the maximum probability. So if data point 1 has a higher probability of belonging to this cluster and lower probability of belonging to this cluster, so we have plotted accordingly. So that data point has been assigned this cluster. Different choices for similarity functions. Okay. So like we saw Euclidean distance, right? But the problem with Euclidean distance is that it is very sensitive to outlier, and it is scale sensitive. So to get rid of these two issues, we normalize the data, right? Standardize the data. That means subtracting mean and dividing by standard deviation. So correlation based distance. So what it does, it eliminates scale and standard deviation differences from the data. So Mahalanobis distance. So it takes into account correlation between measurements. So these are different measures basically, measurement to for similarity between data points, similarity functions basically. Manhattan distance. So just like Euclidean distance, but what it does, instead of taking square and root, what it does, it takes absolute values of the differences. That's all it does. For categorical data, we have different methods such as matching coefficient, Jacob coefficient, and stuff. You can do some online research on all these and understand better what they are basically and how they function. Then there is a data is mixed, like it has categorical as well as continuous variable. Then there is a method called Grover's distance measure. So you can again go and search online and find out what they are. So measuring distance between clusters. So there are different methods to measure distance between clusters. So the first one is called single linkage. So what it does is basically it calculates, what it does, it pairs data points between these two clusters. So all the possible pairs. Okay, so this and this. So it makes pairs of data points from one cluster to data points from another cluster, and looks for the pair which has got the closest, which are the closest, the shortest distance. So in this example, let's say record A from cluster 1, which let's say this is record A, and record B from cluster 2, this is this. They are closest. So this closest, so we look at the closest pair and look at the distance. That distance becomes the distance between these two clusters. Complete linkage is just opposite of this. We look at for the we look for the farthest pair. So whatever is the farthest, that becomes the distance between these two clusters. And in average linkage, what we do, we look at all the pairs, possible pairs between these two clusters, and take the distance, calculate the distances, take the average, and that becomes our average linkage. This is how we calculate the difference between clusters. So now let's look at hierarchical clustering. So there are two methods as we saw, right? The first one is agglomerative method. It is a bottom-up approach. What it does is it has very simple, steps. So initially it starts with considering each data point as one cluster. Each data point is considered as single cluster. And then what it keeps joining two clusters based on similarities until we reach a point where all the data points have come under one cluster. So that is why it is called bottom-up approach. Start with each data point as a single cluster, keep joining them based on similarities, and then finally reach a level where all data points have come under one cluster. Divisive method is top-down approach, just opposite of this. So what it does is you initially consider all the data points as one cluster, put all the data points in one cluster, and then keep dividing them into smaller clusters until we reach a point where all the data points, each data point has become a cluster in itself. So how to do hierarchical clustering in R? So there's a library, the package called cluster. Okay. So in this package, you have a function called Agnes. And again, I've used the same data and it has different arguments, metric, Euclidean distance, and then method complete, like, the distance between cluster, complete, average, and single. So we have taken complete. And then this builds this agglomerative clustering. So let's see, it looks like this. Okay, this is what it has built. You see each data point in the beginning, they're each cluster in their own, right? So each data point is a cluster. And then we have joined them together like this, to make one cluster. These 2 points have become one cluster here. Likewise, we keep going up. So this particular line has joined these clusters, these two clusters. This one keeps all these clusters under itself, like in all the data points. And then it becomes one cluster, all data points under one cluster. And cut tree is a function, you can use that to get the number of clusters you want. If you want k as 5, you want 5 clusters, so you use this function and use the name of this model that we have built here, k is equal to 5. It will divide all the data points into 5 clusters. So first one has been assigned to first cluster 1, second to second, third, fourth, fifth one has been assigned the second cluster, likewise. This is how it is. So there is another function in R which is part of the base R stats. It's called hclust. You can use hclust also to build these kind of hierarchical clustering. So thank you so much for your patience. I hope this presentation has been useful to you. And I've given you the basics. I've given you the foundation. And you need to do a lot of research, go online, read more, and practice more. The more you practice, the better you get at it. Clustering is a very interesting topic. So thank you so much again, and if you like this video, like, share, and subscribe.